Welcome to Study Loop.
So, once again, welcome to a new problem. This time we have a table with the height. So, this is the information we're given. The height of the table from the ground is given as uh, 2.60 meters. So, that's the table height from the ground from right here. So, the height is 2.60 meters. And also, the table extends a little bit that way. So this is the information we're given. And there's a block right here at the edge of the table. And we're going to call it B. And the mass of that block, uh, the mass of block B is given as, so the mass of B is given as 4 kilograms. And as you can see, the initial velocity of B is 0 meters per second since it's not moving. There's another block coming along, and we're going to call that block A. We'll call that block A. It's moving this way. Block A happens to have a mass of 2 kilograms. And then the initial velocity of block A happens to be given as 8 meters per second. So that's what we have at the beginning. And then eventually what's going to happen is that this is kind of like a before scenario. And then you have an after scenario. So afterwards, block B, it's going to be knocked over, and its travel will go all the way up until the ground level. Okay, it's going to go up until the ground level. And block A, on the other hand, will travel towards the left. So we'll say the final velocity of block A is velocity A final. It's going to be -2 meters per second. -2 meters per second, because A is knocked to the left. So this is going to be -2 meters per second. Remember, if you think about the X and Y axis, the x-axis is positive that way, and the y-axis is positive that way. So going that way will be negative. That's the information we're given. Also, at the ground level, the height is 0 meters. Okay, that's the height at the ground level. So this is the information we're given. What we're looking for is the velocity on the ground level. So when B gets to the ground level, we want to find the velocity of B at the ground level. That's why we're calling it this G. So this is at ground level. That's the velocity of B. In this particular problem, we're going to be employing the law of conservation of energy, or rather, both the law of conservation of energy and the law of conservation of momentum. Law of conservation of momentum, which says that the initial momentum of the system equals to the final momentum of the system. The initial momentum is, for A, for example, it's going to be mass of A times initial velocity of A, plus mass of B times initial velocity of B. That has to equal mass of A times final velocity of A plus mass of B times final velocity of B. That's the first part. Our goal is to get this final velocity. So that's this velocity when it just takes off. That's what we want to find out at this point. That's a mid step before finding the velocity before it hits the ground. So it's a two-step process. Remember, the initial velocity of B is 0. So that means this part is going to cancel out. And you can see that moving things around, if we move this one to the left, we have a mass of B, final velocity of B equals to mass of A, final velocity, initial velocity of A minus mass of A, final velocity of A. And so the final velocity of B becomes equal to mass of A, initial velocity of A minus final velocity of A. We divide that by the mass of B. We plug in the numbers. So mass of A is 2 kilograms times these two values. Initial velocity is 8 meters per second, and then we subtract the final velocity of A, which is 2 meters per second, and then we'll divide that by the mass of B, which happens to be 4 kilograms. So that's what we're doing at this point, and we're going to move on to the next page just to build up on the steps we've covered so far. So we have 2 kilograms. We have 2 kilograms times the initial velocity of A, which is 8 meters per second. The plus, the minus, and the minus, these two minuses give you a plus and 2 meters per second. And then you want to divide that by the mass of B, which happens to be 4 kilograms. Simplify that problem, you get the final velocity of B, which is 5 meters per second. Okay, 5 meters per second. That's just the initial step. The next thing that happens is that we have two locations. We have this location where the block is going that way. So we need to find the initial kinetic energy at that point, plus the initial potential energy. Remember, potential energy is mgh. So initial potential energy of block B. And then once it gets to the ground, we also want to find the final kinetic energy of B plus the final potential energy of B. Going back, remember that this final height right here is 1, and this is the final height for B. And so coming back using the law of conservation of energy, using the law of conservation of energy, we get to see that the energy at the top, which is Ke, B, initial kinetic energy plus initial potential energy of B, equals to final kinetic energy plus final kinetic energy of B at the ground. Remember, this one is 0 because the final height is 0 at the ground level. This ground level height is 0. So this whole thing is just going to be the final potential energy of the system. The final potential energy of the system is going to be 0. In terms of units, this is 1/2 MB VB final squared. That's the initial kinetic energy, because at this point we had a final velocity from the momentum problem. So, you just want to make sure you take note of that this is the final velocity from the momentum problem, and it becomes the initial velocity when it comes to kinetic energy. And so you have to take note of that. And then we also have mass of B. This is also mass of B, just remember that, mb. Okay, so then the mass of B times acceleration due to gravity times the height, initial height, this height right here, we can call it the height, the initial height of B. It's the same one, it's 2.6 meters. And so we come back and see we have an initial height of B becomes equal to the final kinetic energy of B. And this is where we're using this final velocity before it hits the ground. So we call it VBG, velocity at the ground level. And that's what we want to solve for. And so, we can multiply both sides by 2. Or another way you can think of it is you can divide by everything by 1/2 mb, that by 1/2 mb, and that side by 1/2 mb. And so you get the final velocity of B at the ground level squared. These two cancel out, so it becomes equal to, and these two cancel out, final velocity B squared plus this 1/2 comes up and becomes 2. These two cancel out, and then GH, the height of block B at the table. So we're going to go to the next page and just simplify the problem. So we end up having that final velocity becomes the square root of VB final squared, square root of VB final squared plus 2GHB initial, 2GHB initial. And then we're going to plug in the numbers. This is 5.00 meters per second squared plus twice times the acceleration due to gravity, which is 9.8 meters per second, times the height was 2.60 meters. Simplify that, and we get to see that when we simplify that portion, we end up having, well, this is a square root problem. So we're going to have square root of 5 squared. So we're going to do it like this, square root of 5 squared and then plus 2 times 9.8 times 2.6. When we simplify that whole problem, we get positive 8.72. So the final velocity of B on the ground is positive 8.72 meters per second. Just remember that you always want to keep the variables up until the end as you simplify the problem. So again, we had block A and B. Block A was moving. It collided with block B at this point, and then it bounced back. So it went to the left, B went to the right, falling downwards. And as it was falling downwards, the final height was 0. So 2.6, we computed the velocity just when it left the table. We call that VB final, and then we use that in the law of conservation of energy to determine the velocity on the ground when the height is 0. Hope you enjoyed the problem. Feel free to send any questions or comment, and looking forward to see you in the next set of problems. Okay, thanks, bye.